Good morning on my behalf. I'm Miika Valtonen from Remion, and we are an industrial partner with multiple major Finnish companies doing IoT for them, from data processing to data collection, data processing, and then data visualization. And we stepped into this project by bring in IoT expertise, and we didn't have a good view what a digital twin is really, and we needed to figure out what is the digital twin concept, and this is something we developed during this project. So a principle of a DT core, a digital twin core, that's like a Lego block that can be used for building digital twins and making the data to transfer between digital twins. And I'm going to run now through some of the basic principles we have put in here. So starting from the Business Finland's sentence where they say that the digital twin for data processing, it's doing three things. It's predicting, for example, product behavior in different environments. It's estimating product service needs, and it's providing product savings guarantee the usage of real products performance information, and so on. And it can provide some added value to some products. And from this view, and from the view of data processing, we see that there's a real product and there's the digital twin. And if we want to get the benefits to be able to predict, estimate, and provide something from the digital twin, we need information. And that information is built on data and logic. And this is something we need to put in the DT core, that building block that can be then used for building the digital twins. So I'll run you through the different parts of that, what will be part of the DT core. And as the topic said, it's a modular block, and that represents the digital twin. And first of all, we have there some storage, and it's something where you can put in some data that comes from outside, or it's either processed within the DT core. Then we have a logic part, so we can process the data within the digital twin and make it more valuable. And finally, we have some APIs for bringing in the data and taking the data out. And in this logic, we have all these characteristics for the operational and data handling. And let's go more specifically through this. So what's in the storage? Here's some examples of the contents that could be within there. So there can be some 3D models, how some crane or other product was built, and or how is it designed from different production stages. And we have the component structures. We can have all that information in there, as well as all the IoT data that's collected from the field. Then we may have some metadata of the data ranges, what's used, and that describes the descriptive data within the digital twin core. And also we want to understand the meaning of the data, so we can store that in the storage as well. And then we can have some management data in the storage space, like of prioritization of data sources. If you're bringing data from multiple sources, so how you want to prioritize them, or parameters for the processing. And the state changes, or the state should be stored of the digital twin state in there as well. And then we can also predict the state changes from the historical viewpoint. Well, then about the processing logic, we can have there are different types of data refinery methods. We can model the data within the storage and how we want to take it further. And in that, we may use, for example, inference trees, different AI models, calculate some simple KPIs. And also on the application level, we may have systems to automatically pre-process the data within the DT core, and also do some abnormality detection within there. And then there might be some processing management also within there, so that keeps the data update. For example, it can be processed at certain heartbeats, different frequencies for different purposes and for different interest groups. And also we may have some alerts that come out from there, and they might be modified by the user feedback. And finally, we have the data interfaces as part of this core, where we can manage the queries from different protocols, and we can make CRUD operations to the data, and we can stream or use batch input and output from there, and provide, for example, SQL access to data analytics. And of course, authentication and user management help in providing it securely. So, having one DT core like this, we can use that to build a digital twin. And here I have an example how we can connect IoT platform that has probably some real-time usage data, and then we have some product design data from engineering. And we may want to have a 3D model that's representing the current state of the machine on the field on a user interface. And for that, we may use the DT core to input the data and then route the data to the user interface from these two different sources. So like the data link that the user was referring to. So here's more probably a specific way of doing that. Another example, if we want to have some information from the field, from services and from the ERP, how the machines are built, and do some data analytics on that, we may want to route the data through the digital twin that combines the data to be a more usable and understandable form, probably on the way. And here we see that all of these surrounding entities around the DT core have their own data storage. So the data is stored there, and this DT core won't be replacing the other entities, but it's only routing the data, or it's creating new data within itself that's then provided to the user interfaces or the interests for what you want to see from the digital twin. So going on, if we have this physical twin now, we have, for example, a crane or a lift truck, and usually we have there an IoT platform, at least from our viewpoint, that's what we do. And we want to, for example, get data from there, from the machine once a second, and we have quite a good view of how the machine operates. And from that data, we can get some benefits, like do the real-time operating status, put that on some dashboards, or do some device management, so on a quite low level. But now, using the DT core, we can build the first level of digital twin. That's an asset DT. And we may want to compress the data time-wise, so aggregate it temporarily, so that every minute we see the state of the machine from the digital twin. And we can provide information from this IoT platform and bringing from other sources as well. So we can create, for example, historical 3D simulations using the mechanical structures of the actual machine as it was engineered, and then we can fusing the sensor information together to get a more complete view of the machine in the field, and also then troubleshoot some root causes from the data. Well, using the same DT core block, so like putting another Lego on top of another, we can build a fleet DT. And there we can get a good view of the whole fleet, multiple assets. So these asset DTs can provide data and combine it to this fleet DT. And we can get like a product family views for a certain operator or owner, for example. And then manage the operations and optimize the products as a whole with different customers, and then the whole service fleet there, for example. And finally, on top of this, we may put a strategic DT that provides, for example, business information to higher level. And here we may have only 1 day or so aggregation time temporarily. So like with the fleet DT, there might be 1 hour. And we usually want to have a bigger view the higher we go with these different DTs. And there's different types of then ROI management, rental business, and other service things, for example, you can do with this type of DT. So having presented this DT block, a Lego block, we can do different types of processing, data processing with that. And ourselves, we have built a prototype on our Regatta platform. That's an IoT platform. And we have developed this Regatta Flow that prototypes and shows and implements this DT core principle. And in a visual way, we can, with nodes, build up the information and doing it at certain heartbeats, then refine the information to a higher level. And if you're interested more in this, you may come to our demo stand then during the lunch session, and we'll have a scheduled demo also going on then during that break. So by this, I want to just finish and thank you for your attention.
Thank you, Miika. I suppose there are several questions about this topic here. This is practical implementation, what can be done with the IoT data. So, anyone? Tatu, of course.
So following this HS score question, how are these DT core layering things, are they somehow visible in this score, or is the score at that dimension giving any more information, or do you see any use for this HS score that was presented by previous presenter?
Well, I haven't thought about that in my mind yet. Really, the HS score is something new to me, so hard to say at this point.
Any other?
Stefano Morelli, TG Zurich. So thanks a lot for the extremely clear presentation. I have a question more about maybe the legal aspects. So what we've seen until now is somehow a passive monitoring type thing. So you're recovering a lot of information and elaborating a lot of information that is provided to decision makers. Mm-hmm. But in principle, digital twin could also be used in a bidirectional way. So as an example, acting in real time if some problem is detected by the machines, an anomaly, as you were mentioning. And my question is there any application towards that? And if there is, what about the legal implications of such a bidirectional access would cause?
I'm sorry, did I understand it right? So you want to ask about the bidirectional access with the DT?
Correct. Basically,
yeah.
I monitor from the software, I realize something wrong is going on, or the AI in my software realizes something is wrong, and I need to take immediate action to avoid an accident. But then, of course, you never know legal implications of what may be caused by such an action.
Legal implications. For me, the legal viewpoint is somewhat different and new, because I come from the research background, more of the technical side. So I guess there's not that much that I can say about that. But of course, there are rules how you can bring in data from different sources, and you have to be making agreements with the source providers of the different data and how it may be collected together and how it can be acted on. And also, like for example, with the crane that's operating there, it's not safe to control it or probably even not to stop it remotely if the source giving this command, it doesn't have enough authentication for that purpose. So you need to consider all these types of things and make agreements on them. I guess that's
not something being discussed. That's my.
Well, yeah, we haven't discussed that much on this in this project ourselves. Thanks.
I could actually further elaborate the same topic about these legal aspects or about the contracts between companies, because we are talking about several companies. There are vendors, there are operators, there may be maintenance companies that should share the data. Do you see this is that kind of as a bottleneck for future applications of these systems, to how to share data, how to create this kind of business ecosystem that everybody's on the winning side?
Yes, of course, that's somewhat the limitation, so that and the questions that are different entities are willing to share the data. Mm-hmm. So if everyone would be willing to share their data, it would be much easier to create new digital twins or different concepts at a higher level. So yes, I see that's one issue that should be solved.
Okay, any more questions from the audience? Yes. Just they won't hear you in the stream.
On your behalf, this DT core, is it based on any standard like PLCS, ISO 10303 or something like that?
No.
So it's kind of your own structure for the data management?
Yeah, it's our own concept or principle, how we want you to build this together, what parts are needed in that. That's, yes.
As a consequence of the last question,
Mm-hmm.
it might be some problems that when you're creating ecosystem, well, there are different actors from different fields. If you don't have a standardized solution for the data management, just a comment.
Yeah, well, these interfaces may be standardized, like what you want to use when bringing in the data and taking the data out. So that helps in using that and combining it with other systems. So we're using standardized, for example, MQTT or for data, bringing data in or out from our regatta flow. So yeah, there's standards for that. And then there's standardized tools that you can do and build the storage and logic with too.